Okay, so guys, let's get into it. So like I said, we sort of started this whole process of graphs and relationships by looking at number patterns, and we're going to sort of continue that same train of thought. All right, so what we need to be mindful of is that anytime we're looking at variables, so remember that lesson, we're looking at types of variables. Anytime we're looking at variables, the relationship between two variables can be represented in several different ways. So we've spoken about number patterns, where we get a list of numbers that have some sort of pattern, and we have had to go and find the relationship between them. That is one way to represent the relationship between variables. Another way that we can represent this relationship or pattern or sequence is through a picture. Okay, so I'm sure you guys have all at some point come across someone who's using matchsticks to make pictures. That is one way we can represent a relationship between our variables. Right, so before we get into this, I just want to remind you of some important words that we use within this section. And obviously, because we are going to start to focus on graphs as we go along, I'm going to start sort of focusing on the specific terminology there. So remember, our two variables that we are particularly concerned with is our X variable, which represents our input value, and our Y variable, which represents our output value. Okay, so an input versus an output value. What we need to remember is that an input value is basically a number that we pick or that is given to us, and we apply a rule to in order to get a corresponding output value. So another way to think of an input value, and if you guys enjoy, or if any of you enjoy life sciences or natural sciences, this would be our dependent variable. And no, it wouldn't. Our independent variable, X. Right, because again, I can pick any picture in my sequence. I can pick any term in my sequence. That doesn't matter. It is independent of the rule. What is dependent though is our Y value. So that would be our dependent variable. And so what we almost need to think of is the fact that we can only get our Y value once we know our X. The value of Y depends on what X's value is. All right, so we have input and output values. We use those a lot when we talk about graphs. If you start thinking more in terms of like the sciences, we can have independent and dependent variables. Okay, and you guys hopefully have heard those terms before, probably in something like natural science, but that essentially correlates with our input and our output. Okay, so we did speak about this on Monday, but I'm just going to remind you. Your Y value in the case of any pattern or any relationship is going to be, in this case, oh, that's not great, is it? In this case, the number of matchsticks we have, or the number of lines. I think I've said matchsticks, yeah. And so it makes sense. I can only know how many matchsticks I have once I know what picture I'm trying to find. So that would then mean that our X variable or our input value is which term we are looking at. Remember, we said terms are any picture or any number in our pattern. Okay, so we've got a whole bunch of matchsticks here. We've got some pictures here. There is a question to start off with, but the first thing I actually want you to find for me, so I'm going to put a little star here, is how many matchsticks are in each picture that I've given you. We have to count here how many matchsticks are in each picture. Okay, so on the chat, you can give me how many matchsticks are in each. So we've got picture, we've got term 1. I want to know how many are in that one. We've got picture or term 2, and you get the picture. No pun intended. Oops. On the chat, I should be seeing a whole bunch of numbers come through for each of these terms or pictures. We're just counting the matchsticks right now. Right, once you do have how many matchsticks are in each picture, see if you can start to figure out what the pattern is. So from picture 1 to picture 2, or term 1 to term 2, term 2 to term 3, what is the pattern? What are we seeing? Nice, guys, well done. Okay, so if we just double check our terms, the first one has 12 matchsticks, the next 19, and the third picture has 26. Now, remember, I've said this to you before. Anytime you have any sort of pattern, okay, in this case, the matchsticks, the numbers, whatever, what we always try and do before we even start worrying about the questions is we try and see what is the pattern. So I can see that from 12 to 19, I've added 7. And from 19 to 26, I've added 7. So my number pattern, or the pattern that I've created with my matchsticks, is that I'm adding an extra 7 matchsticks each time I build a new picture or a new term. So that makes the first question that I have actually asked here quite easy, right? I now can pretty confidently say that I know how many matchsticks will be in the fourth term. We know that the first 3 terms had 12, 19, 26. We know that the pattern is to add 7. And so all I would now need to do is add 7 to my third picture in order to get the fourth. So our fourth term, or term 4, will have, and a lot of you have said, 33 matchsticks in its picture. Okay, so before I carry on, there's a question of why is it 7? So Lillian, if we go and have a look at the numbers, so this has 12 matchsticks, the second picture has 19 matchsticks, and this third picture has 26 matchsticks. So if we go and line up sort of the image that's repeating in each of these, I can see that I sort of have the star shape, and I obviously can't highlight very well, but we have the star shape. If I now move on to the next picture, there's sort of half of my star shape, and there's the triangular side that's moved on. What I now see is that all of these matchsticks that I'm going over in green, I have now added on. And if I count how many that is, whoops, 4, 5, 6, 7, I'm adding an extra 7 matchsticks, right? I can then go over to my next picture and I can see the same thing. So if I highlight everything that is sort of continued over from the second picture, I get something like that. And then if I go and see how many matchsticks I've added, there's 1, 2, 3, 4, 5, 6, 7 matchsticks that I've added. And so because every time I'm adding an extra set, English today, because every time I'm adding an extra 7 matchsticks to create the new picture, I've either seen that through the numbers, 12, 19, 26, or I've seen that through the pictures, so sort of what I've highlighted in the orange and the green. And so the reason it's 7 is because that's what I'm adding extra to each picture in order to get the next one. So the fourth term would now have an extra 7 matchsticks added to it. Perfect. Don't you stress. Like these picture ones, sometimes it is quite hard to count. What I often do is exactly what I've done here. So I sort of highlight or go over the lines that I know I've counted, because I also sometimes count wrong and then cause my own chaos. All right, so guys, what I want you to try, and some of you have already started trying this, but I'm going to give everyone a minute to give it a try, is for you to write down a rule that represents this pattern. Now, remember on Monday, we discussed the difference between a rule and a description of a pattern. So remember, I'm not asking you to describe the pattern. I'm not asking you to say, I'm adding 7 matchsticks each time. That's a description of the pattern. My rule is algebraic. So we should have something like y equals, and then something going on with x, something going on with our input value in order to get our output value. So a rule is an algebraic equation that we have that will allow us to work with this pattern for any term or any outcome. Shouting outside. Right, so let's try this rule. I see again, some of you have already tried it, but I'm going to give everyone a minute just to have a go and have a try.
Don't worry, we can't hear any noise.
Okay. Yeah, I don't know what's happening. Okay, and guys, remember I told you that X is your input, Y is your output. Those are the 2 types of variables that we are working with currently in this graph section. And so those are the 2 variables that we need to have in our algebraic rule. We did quite a fair amount of this on Monday, and we have done it in our number pattern section as well. So if you are struggling a little bit, we can go, or you can go back and watch those videos, both the number pattern and Monday's lesson, but we have spoken about that. So let's just be very careful of using our 2 variables. Okay, 30 seconds. Righty. Okay, so guys, if you're struggling to do the rule, I'm going to explain it again here. I probably won't do a lengthy explanation again. So let's listen up if we've struggled with that. It's essentially what I spoke about on Monday, but let's just do a quick recap in case we've forgotten. Okay, so our rule, remember this is where we are now using an algebraic equation. So it should be y equals, so our output value is found by doing something to x. So we need to now have an expression that has x in it that tells us what we're doing to x in order to get y. Now, lots of different ways you can visualize this, but we know that our x values and our y values represent 2 different bits of information in this pattern. Our x values, remember, represent the position of my term, or in this case, which picture I'm talking about. So term 1 or picture 1, term 2, picture 2, 3, 4, etc., etc. We know that picture 1 had 12 matchsticks, picture 2, 19, etc., etc. We've worked the rest out. So what we are trying to achieve here, whoopsie daisies, is we are trying to find a rule that allows us to get from x to y. That's the goal when we want to write down a rule for a pattern. So I need to ask myself, how did I get from 1 to 12? How did I get from 12 to 19, 3 to 26, 4 to 33, etc., etc., etc.? Now, I've told you, whenever we are adding the same thing every single time, so in this case, I'm always adding those extra 7 matches to get my next picture. It doesn't change. I'm not all of a sudden adding 12 matches. I add an extra 7 from one picture to the next, and that's going to give me my new picture. Whenever we know that it is a constant value that I'm adding or subtracting, that value is our coefficient to x, right? Obviously, that value is important to us. It's something that we're doing consistently from one term to the next. And so it comes into my rule by being the coefficient to x. Then we always double check if we have to add or subtract anything to that in order to get our output. So if we take an input of 1, 7 times 1 gives us 7. However, we want an output of 12. So to get from 7 to 12, we need to add 5. We always double check ourselves. So let's try with 2. 7 times 2 gives us 14. I don't want 14, I want 19. If I add 5, I get 19. And so I'm now able to complete my rule in that y, so the output value or the dependent variable, is equal to 7x plus 5. If I want to get my output value, I need to take the input value, times it by 7, and then add 5. And that is my rule for my pattern. Okay, Hayden, I don't understand. I have written 26 down, unless I'm maybe losing the plot a little bit. So I did write 26 down. I haven't written 6 down unless I've done it somewhere else. You can just let me know. But I have got 26 here in my table. And like I said, unless I put it somewhere else that I'm not seeing, just let me know. Alrighty, guys. So that is how we essentially establish a pattern, how we then go and find the rule for that pattern. I'm just going to stop here for a second. Does anyone have any questions before we move on with this example? Okay,
So what I mean is the place where you have written term 2, picture 2 is 19, term 3, picture 3 is 6.
Thank you. I obviously erased it. Thank you so much. Thanks, Hayden. I did not see it until I moved my screen. Thank you very much. Okay, Lindo.
Hi, ma'am.
Evening.
Ma'am, can I ask, is it if I say 12 minus 19, the answer is going to be -7. So I'll just change that -7 to a +7, and then my answer is 7. Is that right also?
In terms of trying to find what you're adding or subtracting each time.
Ma'am?
Is that what, so Lindo, are you saying, is it fine to do that to figure out what the difference is?
Yes, ma'am.
Yeah, that's absolutely fine. So if you start with term 2 rather, and you see how you got term 2 from term 1, that's absolutely fine.
Thank you, ma'am.
Sure. All right. Sipilele, the rule is exactly the same for 26 and 33. So this rule of 7x plus 5 is exactly the same, and I'll prove it to you now. So if we take our input value of 3, cool, 3, and we apply the rule. So our rule is y is equal to 7x plus 5. X is the value 3. So 7 times 3 plus 5 is 21 plus 5, which gives me 26. And that is the output value that I have there. If I do the same thing with 4, 7 times 4 plus 5 is equal to 28 plus 5, which is equal to 33, which is my output value. So guys, what's really important to understand is that once you have a rule, that rule applies for any term in your pattern. Whether you want the 3rd, the 4th, or 5th, or the 78th, 79th, 80th term, this rule will now apply for any pattern or any picture in this particular sequence. Sipilele, I hope that makes sense, and we're all good there, but obviously just let me know if we're not. Okay, so guys, I'm just going to make a little note here, actually. This, good. I can't spell applies for any term. Alrighty. Okay, now that's a really good question that Sipilele has asked us, because it's now going to lead into the next question that we have here. Okay, so the next question, I'm just going to make this a touch smaller so we can still see our pattern, is asking which term or which image number will have 110 matchsticks. All right, let's just break down what this question is actually asking. If I go to my pattern and I kept drawing matchsticks all the way until term or picture 110, how many matchsticks or how many lines will I have to draw in picture or term 110? Okay, now remember, we have a rule that we've just established. We know that our rule is y equals 7x plus 5. Right, I'm going to just make this a bit bigger again. So here's our rule, y is equal to 7x plus 5. And if we relate this rule back to what we said earlier, so back to what we said y represents and what x represents, we know that y is the number of matchsticks. That's our output. And we know that x is our term or our picture number. Okay, so our rule gives us 2 bits of information. Remember, we said we're working with variables. We have 2 variables that we work with, x and y. And our rule or our equation here actually works with both of those variables. So because we have this rule and because we now know that we're looking for the term number, so let's read the question again. The question says, which term or image number, so we're being asked to find the x value, we'll have 110 matchsticks because we've been given the y value. So in this question, we've been given all the information we need to go and solve this question. So we're going to substitute in what we know. So we know we've got 110 matchsticks. We are looking for the image or the term number. So we have got an equation that we now need to solve for x. 110, the number of matchsticks, is equal to 7x plus 5. So we're going to use our inverse operations in order to solve this equation. So remember, inverse operations means I need to do the opposite. It's an equation. That's why we do inverse operations. So the first thing I'm going to do is I'm going to subtract 5 on both sides. And so I've got 105 is equal to 7x. Once I've done that, I know that my next inverse operation that I need to do is I need to go and divide both sides by 7. Because remember, I want x alone. That's the point of solving an equation. So 105 divided by 7 is equal to 15. Okay. So what we now know is that term or picture or image, whatever you want to call it, 15 will have 110 matchsticks. So what you've established here is if you kept drawing this pattern all the way up to the 15th term, so all the way up to the 15th picture, in that 15th picture, you will draw 110 lines or 110 matchsticks. Alrighty, so this is the importance of us being able to work with an algebraic rule when it comes to different types of variables. We can now go and find out a whole bunch of information about the pattern or the sequence that we're working with if we have a rule or a relationship that we can see between our 2 variables. And what, like I said, what we're eventually going to do is we're going to eventually take this relationship and draw a graph to represent it. Okay, so take your screenshots. Again, if anyone has any questions, now's the time to raise your hand and ask. But again, the importance here is that we have found a relationship, we found a rule, we can now pretty much do anything in terms of this pattern with that rule. Verona?
Ma'am, where do you get 105, ma'am?
Okay, so the 105, I'm just going to add a little in-between step here. The 105 has come from me subtracting 5 on both sides. Remember my inverse operations, I'm going to get rid of this plus 5. So that means I'm going to subtract 5 on both sides of my equation because plus 5 minus 5 cancels out. And then I'm doing the inverse on the other side of my equation.
Oh, thank you, ma'am.
Okay, good. Okay, so guys, yeah, really importantly, that 105 has come from my inverse operations. Right, good, grade 8s. Okay, so what we need to bear in mind is that, like I say, variables, especially when there's a relationship that exists, can affect each other in different ways. And this is essentially why it's so important to understand the types of variables that we're working with, input, output, independent, dependent, and how they affect each other. And I said to you in our first lesson that this idea of relationships between values has very important real life applications. So I gave you an example of like a business and their profit, but there's more sort of, I don't want to say basic examples, but there's more applicable examples to even you as a 13, 14-year-old. Right, so let's have a look at this first one. The number of calls you make and the amount of airtime you have. So let's think about this. And I want you guys to put one word answer on the chat for me. If you make, let's say, and now I have to phrase this properly. Okay, if you make 100 calls, would you pay more or would you pay less than if you made 50 calls? So I'm going to try and write my question out. So would we pay more for 100 calls or more for 50 calls? I'm clearly not an English teacher. Okay. Right, nice. More for 100. Good, guys.
See, you were understood, Teacher Sam. So you're doing really.
Sometimes I say things and I'm just like, that made absolutely no sense. In my brain, it made sense, but to no one else. Good, guys. Okay, so we would pay more for 100. And this is sort of, again, this real life application. If you have a cell phone contract or if you're needing to buy data or airtime, you need to know how much you need to buy or how much you're able to spend according to whatever you have. So let's say you only have 100 Rand to buy airtime or to buy data in a month. You need to make sure that you're not using up those calls too fast. You need to make sure that you are using your money appropriately. Okay, now this could have many, many examples. If you think of something like an electricity bill, right? If you have a prepaid meter and you put in 200 Rand electricity, that is how much electricity you have to work with. The more electricity you use, the more you have to pay, all right? Obviously, load shedding creates a whole new drama, but the essence is the more you use, the more you pay. The more airtime you use, excuse me, or the more calls you make, the more you're going to pay. And so if we now start to imagine this graph scenario, if we now start to imagine the graph or visual representation of what this would look like, I'm going to draw some straight lines because we always draw straight lines for our axes. We can start to imagine this. Okay, now remember two types of variables. We have got the number of calls that we make and the amount of airtime. We need to decide which should go on our x-axis, which remember is our independent variable, and which should go on our y-axis, which remember is our dependent variable. Okay, now I know this is something that we struggle with. So I always think in my head, which variable or which scenario affects the other. So the number of calls I make affects the amount of airtime that I have, right? The more calls I make, the less airtime I'm going to have. And because the number of calls is affecting my amount of airtime, the amount of airtime depends on how many calls I make. If I make no calls, I'm going to have a lot of airtime. If I make a lot of calls, less airtime. And so just through working through the scenario in my head and seeing which one affects the other, I'm able to decide which is dependent and which is independent. So my independent is my number of calls, and my dependent is the amount of airtime I have. Okay, now I'm not going to put numbers on here. We'll get to scenarios like that. But basically, let's grab a color here. As I increase the number of calls, I'm increasing the amount of airtime I use. So as a graph, the more calls I make, the more airtime I am using. And so already I can start to visually understand what the effect of making a large number of calls is on my amount of airtime that I'm going to have to spend. And this is why graphs are so super useful to us. They can visually show us a relationship between variables. So between these X and Y variables, I now have a visual understanding of what's happening. Now you get lots of different types of graphs to represent a whole bunch of different types of relationships, and we'll chat about those as we go along. But excuse me, often visually seeing a relationship helps us understand that relationship a lot better. Alrighty, any questions, guys? Hands up if we do. Now, I know that this isn't something that you're starting to think about yet, but this idea of graphs is not only useful in maths, we do a lot of graphs in maths, but if come end of grade 9, grade 10, grade 11, you decide you're going to change to maths lit, graphs is also very, very much used in maths lit. So regardless of which math subject you're planning on doing, this is a really important concept that we need to be comfortable with. All right. If you haven't taken screenshots, I'm waiting 30 seconds and we're going to screenshot, or then I'm moving on. So screenshot. Good. Okay, so let's think about this second scenario over here. A lot going on. We've got the number of matches in each picture and the number of triangles created. So I'm not going to do anything. I want you to tell me, am I going to need more matches for more pictures or less matches for more pictures? Hopefully my words made sense this time. So do I need more matches for more pictures or less matches for more pictures? Okay, nice, guys. Some of you mixing it up. All right, so guys, one picture, 3 matches. 2 pictures, I now need more matches because here's 3 matches, here's 5 matches. 3 pictures, I now have an extra 2 matches, so 7. As I increase the number of pictures, my writing today, I am also increasing the number of matches. So for example, I have got 6 pictures here. If I now want to make the 7th picture, I'm going to need more matches. If I want the 8th picture, I'm going to need even more matches. So as I make more and more pictures, I need more and more matches. All right, and often, especially at this level, it's often going to be a relationship of the more I do something, the more I'm going to need of something else. Not to say that we can't have a situation where as we have more, we have less or need less. But again, think about it in your head without like a mathematical brain. If I want to build more pictures, I'm going to need more matches. It's not possible for me to build another picture without more matches in order for me to continue the pattern. All right, so we need to be very mindful of what the scenario is and how it now relates back to that whole idea of what is the relationship between my values or my relationship in the context of the question. Right, so a couple of you said less, so I just want to make sure we're all happy with why more pictures means I need more matches. If not, let's raise our hands. Okay, so the question that I've gotten, and I won't say who because it's a direct message, is don't we need less because we're adding on to matches already? All right, so I hear what you're saying. You've already got the foundational picture and you're just adding on, but the mere fact that you've said you're adding on means that we need more. Okay, so for example, if I only had built the first 5 pictures, I cannot build the 6th picture without having those 2 extra matches. Yes, it's only 2 extra, but I still need more than what I originally had for the 5th picture. So the 5th picture, I need 3, 4, 5, 6, 7, 8, 9, 11 matches. This next one, I need 13. So yes, it's only 2 extra, but I still need more matches than what I needed for the 5th picture in order to build the 6th picture. So I completely understand where the thinking is of saying less. I completely get it. But just think about the fact that because we're adding on, we're going to need more each time. All right. Like I said, I completely am on the same wavelength as you. I get it. But because we're adding, we're going to have more. And Andelia has a very nicely identified already what that relationship is. Well done, Andelia. Alrighty, guys, we're not going to have time for a full-on brain break, but I want you to just take 2 minutes, have a stretch, move your body before we carry on. For 2 minutes, like I said, not a proper full-on brain break. Let us just have a move. I just want to see how much we still got left here. It's not the end of the world either way. Sounds like there's a horse outside my room. It definitely is not a horse, but obviously rain or something. But it's obviously blowing so hard, it sounds like a horse. Okay, so let's have a stretch. Even if you stretch while you're sitting at your desk. Oops. Okay, guys, so we're going to wrap this up, just making sure that we understand these two different types of values that we work with, or two different types of variables that we work with. And what I'm actually also going to do as we end off is related back to a concept that we did your first term, which is the idea of ratios and rates. And I know it's a section that some of you really don't like, but again, this has such a far-reaching application and such a far-reaching can't think of another word right now, but it sort of goes in a whole bunch of different sections in math. So it's really important that we get it. Okay, so again, the two really important variables that we're going to work with come down to our input and our output values. Now, we have discussed both of these, but just to formally put down into words what each of them are. So your input value we know is represented by X. Okay, if we just pop down to our output, this is represented by our Y variable. So those are the two variables, and they each represent different things. So our input value is the value we apply a rule to get an to get an output value. And this rule, so the specific rule that we use, represents the relationship between input and output. Okay, so when we are going to work with an input value, it can be any input value, and we'll discuss this more as we go along. But what's important is that we apply a specific rule to that input value in order to represent the relationship that exists with our input and our output value. Excuse me. So if we go back to this idea of profits, right? We're not going to just have some like input value of R1. That makes no sense unless your business is selling, I don't know, chappies or something, but I think even chappies are more expensive than R1 these days. Our input has to reflect, again, our scenario, but the rule is applied to our input value in order to get an output value. We need to apply the relationship that exists in order for us to understand and to potentially then draw a graph that visually represents what's happening between X and Y. Right. That therefore means that our output value is the value we get once we apply a specific rule to X. Right, and Sabiso has put, oh golly, Miss Molly, an example of a rule there on the chat. Okay, so as an example, we could have something like y equals 2x plus 1. I'm just stealing Sabiso's idea here. That's an example of a rule whereby our input value x, hello, there we go, our input value x being put into that rule is having that rule applied to it, or is being affected by that rule in order to get a corresponding output value. Now, guys, honestly, there are an infinite number of rules that we can apply. Quite literally, you could make anything up. Here we go. You could make anything up, all right? As long as you are applying that rule consistently to X and Y, it will represent a relationship. All right, so it's a Biesel here, and Tebogo has pointed this out for me, would be the, guys, my English tonight. Okay. This rule could apply to a bunch of different scenarios. So if I'd given you values for the airtime question, we could definitely find a rule for it. I didn't give you values, so it's not as easy to find a rule. But if I do, and as we have been doing for the past two lessons, we can find any rule. And this is where our input and output values come into play. Oh, alrighty. So it's really important that we understand what an input value is, what an output value is. Remember, we also spoke about the fact that your input value is your independent variable. If you want to think of it like that, whereas your output value or the Y variable is your dependent variable, because Y depends on the rule being applied to X. And so we can also think of that in terms of that. All right, so guys, it's going to be really important for us to know how to work with these two variables, very much like what we've done the whole of today's lesson. Because, excuse me, having this rule applied or this relationship applied in rule form is going to be really important for us to draw graphs.